Hey, what is up? Good evening. My name is Mike, and in this video, I just want to share with you one of the most exciting topic in physics and one of the most interesting topic, of course, of all time. So, if you are here for the first time, please don't forget to subscribe, like, and share your friends. Okay, so in this video, we'll be discussing just an introduction to what is radioactivity and what are some of the what are some of the concepts that you're supposed to know before you go and write your final exams. So now, just on the brief introduction, and then in the next chapter, now we shall come and see what are some of the mathematical concepts behind radioactivity. How can you write some of the equations that are concerned with radioactivity, radioactive decay? How can you determine the half-life of that radioactive isotopes? Okay, so just stick around and pay attention if you want to just learn more and, of course, make your life easy. So please, let's jump right into this. Okay, so the idea about radioactivity, or what is radioactivity? Radioactivity is simply the production of radioactive elements, or the phenomenon of producing radioactive rays, or if you want to call them radioactive elements. So what is indeed, or what exactly is radioactivity? When you talk about these rays that we are talking about, I'll give an example. For instance, when you switch on the light bulb, you receive what is called light. But in the actual sense, when this light is viewed from a distance, where on that particular distance you are on the dark side, and then you are kind of viewing the light, you discover that light is made up of particles, or the rays that at some point come from one single source, and then they are just scattered in the atmosphere, thereby converging at some point, producing light that we see, which enables us to identify things that this is what, and so on and so forth. Okay, so radioactivity can be seen in many examples, industries, or just a simple example, like for instance, when someone is pointing at you the remote control, and then the light is on. When they press a button, the light is on. Then they press some kind of a button, volume up or volume down, or whatever the button they'll press, you discover that something is going to happen on the television or the TV set. Meaning the rays are just being sent via in the TV set, and then it has performed some kind of operation, which you as a viewer, you're able to tell, to say the remote is working. Okay, so don't forget, radioactivity is simply the process of emitting radioactive rays. And then from there, we will now come and discussing the details of what is the nature of radioactivity. So radioactivity can be understood to have many influences, okay, on so many things. Okay, so you discover that these rays that are produced from the source that are regarded as to be radioactivity, or performing the process of radioactivity, you discover that they will cause some certain substance, okay, to change from their initial state to something else. For instance, you discover that you are going to discover that even the sun itself can produce some of these radioactive rays that can have impact on us human beings. Probably one of the impact known so far is that they can cause cancer on our body, because the sun itself comes with some of the radiations that can cause cancer. Okay. And then you discover that when the nature of radioactivity can also kill the bacteria, animals, organisms, or they can also kill plants. So it's quite very dangerous when you are dealing with radioactivity. And then also each one of us have had this experience where you are taking a photo by back in the days where smartphones were not so much available as at now, as compared to now. You'll discover that when the cameraman captures you, then the photo, once the photo is developed, or rather it is produced, it is darkened at some point. And that point, or rather that action of darkening of your photo or your photographic picture, means that radioactivity has just actually occurred, meaning some rays, some radioactive rays have just striken on the photographic film plate, and it has actually reacted in some sort, or if you can agree to that, it has reacted, meaning forming some kind of unexpected picture, okay, which is darkened because of this radioactivity. The other nature of radioactivity can be understood as when they are produced within the atmosphere, they are knocking out the air molecules, okay? They are knocking out the air molecules, meaning removing so much of the electrons, leaving much more of the protons, okay, within that particular element of oxygen. Okay, so they knock out the element from the air molecules, okay? That is also one of the nature of radioactivity. And then we'll also be looking into the issue, or rather understanding how we can now detect these rays that are coming from different sources. How can we know that there is a source of radioactivity occurring? There we can also, how can we determine that? Okay, so there has been some of the instruments that has been actually produced by scientists, physicists, trying to assist us human beings, and also to protect us from those hazards that can actually cause some kind of a bad thing on our body, protection from cancer and so on. And then lastly, not the least, but we shall look at the types of radioactivity. The types of radioactivity, in summary, there are three major types of radioactivity. The first one is alpha radiation, beta radiation, as well as gamma radiation. So these are the major three types of radioactivity. Get to understand these major types of radioactivity, because they are the one that comes in the final exam. They'll ask you what is the difference between an alpha particle and a beta particle, or what happens when a substance is producing rays that have kind of a property of a gamma ray. What will happen after that when an element is emitting that kind of rays, or the particles? What happens when a certain substance is producing some alpha particles? What happens to the mass number? What also happens to the proton number, or rather the atomic number? So, ladies and gentlemen, these are some of the critical things that we shall look when you come back in the second video. We'll be looking at now in the details of each one of these that I've just talked about, but much more of the detection, as well as types, as well as also the nature. But I believe that you have gotten one or two, three things concerning what is radioactivity all about, and what the nature, the detection. Of course, the detection, one of the most common detection about radioactivity is the GM, or the gigamolar counter, which is one of the famous instruments used to detect that there is a source, or there is something that is producing radiation, or some kind of random processes are occurring, radioactivities are occurring. So we can use the gigamolar counter to measure the doses, or rather the levels that source is producing. And there's also, of course, the crowd chamber, as well as some diffusion chamber, and so on, as well as the types. And then in that video, our main focus will be on the decay. Okay, so on the equations, like for instance, we'll have something like okay, so something like this produces that. Let's say, for instance, and then you can just say x, okay, maybe 237, maybe 93. Okay, so this is what we shall look at when in the next video. So please don't forget to subscribe and ensure that you'll be part of the next lesson that we are going to do, and just understand the simple techniques of how to write decay equation. Okay, when this substance americium is undergoing it's decaying by emission of the helium, which is an alpha particle, and then what will happen to the mass number as well as to the proton number or atomic number, what will happen after it has emitted. And of course, this same americium 237 can also undergo a double decay after the helium, after emitting the alpha particle, which in nature is an helium atom. It can also undergo the emission of beta particles, which is in nature an electron. So don't forget to subscribe and be part of the next video that I'm going to produce next week or this week, any day, and get to know how you can just answer the questions without fail. So that's it for today under radioactivity. Thanks for watching. Don't forget to subscribe, share, and like. Of course, share to your friends, their relatives. The exams is just around the corner, so these are the key concepts, and this is one of the most topic which is not taught in schools. So try to utilize this opportunity. If you're having challenges, please don't forget to drop down your comment in the comment section below. It's bye bye.